Day 3, finding volumes using shell method. As with anything, we run into a problem with volumes of certain functions. Find the volume of the region in the first quadrant bound by y equals negative x squared plus 4x when it is revolved about the y-axis. So here we have, if you factor out an x here, we would get 4 minus x. So 0 and 4 are the zeros, and then a is negative, so this parabola opens down. So here's the parabola right there. And if we're going to revolve that from 0 to 4, by the way, around the y-axis, then here's halfway around, right there. And then with what we know, we could we could pick a y value and do a washer method. But the problem with this is that these two are the same function. So how do we subtract the same function and get a value that's not 0, right? So when we have the same function, we got a problem with the washer method. That's when we'd use shell method. And here's the shell method. We're going to pick an arbitrary x value. And then instead of doing washers, instead of stacking up circles or washers and adding up the areas and getting volume, we're going to add a bunch of cylinders. So here's one cylinder. Now if we took another cylinder here and added up the area of this cylinder, and then the next one and the next one, we'd have an infinite amount of cylinders making up this shape rather than circles or washers. So the shell method is using cylinders instead of circles. Now if you take a cylinder and cut it on its side and lay it open, what kind of shape are we going to have? Can you visualize that? A rectangle, right? We're going to have a rectangle if we cut it down the side and open it up. So we're going to have something like this. This side right here, the top side, that is the circumference of the circle. So this is 2 pi r. That's circumference. And then the height of the rectangle is just the height of the cylinder. So the area, remember we integrate area to get volume, is 2 pi r h. So that's what we want to integrate when we do the shell method, 2 pi r h. Well, let's find the answer to this, find the volume. We're going to integrate from, the area that we're integrating, not area, but the area that we're picking x values in is this right here. So we keep picking x values in this area to get all of those cylinders, an infinite amount. That means we're going to integrate from 0 to 4. 0 to 4. You can pull the 2 pi out front if you'd like, it's a constant. The radius goes from the the y-axis to whatever x value you're picking. So there's the radius of that cylinder. So radius is the x value, and the height, when we pick that x value, whatever x it is, we plug that in to find the height. The height is going up to the curve. So that's the height. Negative x squared plus 4x dx. It wouldn't take much to finish this. Negative x to the third plus 4x squared dx. Distribute through. 2 pi negative 1/4 x to the fourth plus 4/3 x to the third from 0 to 4. I'm going to cheat. Negative 64, that's plugging, 4 to the fourth is 256 divided by 4 is 64. There's the negative 64 plus whatever 4/3 times 4 to the third is 64 is. Let's quickly get that. Math number 9, math, change it to a fraction. So 128 pi over 3. There we go. We'll speed it up a little bit. But the setup's the important piece, right? Getting to that piece right there. There's the setup. Find the volume of the solid defined by y equals sine of x from 0 to pi rotated around the line x equals negative 2. Yeah, it's kind of down the middle. Sine of x. Here's pi over 2. Here's pi. We're going from 0 to pi. And sine goes up to 1. So it goes up to 1 at pi over 2 and back down to 0 at pi. Yeah, around the line, x equals -2. So pi is 3.14, so it's not quite that far, about that far. Let's call that -2 there. And then halfway around would be over here somewhere, I'd imagine. 0, yeah, let's say over here. Something like that. Well, now if we're going to use shell method for this, we're going to pick this arbitrary x value somewhere, and halfway around would be over here somewhere. And we're going to rotate this cylinder around like this. You guys know what a bundt cake looks like? Isn't that kind of a bundt cake? Where we're going to rotate all the way around. You know what those look like, I guess. So that's what it looks like. We're going to integrate from 0 to pi because we're going to pick these x values. Here's maybe the next cylinder and the next cylinder and the next cylinder and the next cylinder. Well, integrating adds up an infinite amount of cylinders. We need 2 pi. The radius is a little tricky now. But here's what I've been telling people all day. Find the endpoints of your radius. Isn't one of the endpoints at -2 and the other endpoint of the radius is whatever x value would I pick? Can you see that in the drawing? So there are the endpoints of the radius. Once you get the endpoints of the radius, it's always either right minus left or top minus bottom. So this one is right minus left. Now, another way to look at this is that there's certainly a distance of 2 here, and there's a distance of x here. So wouldn't x plus 2 make sense? Well, that's what you get when you have x minus -2. You end up with x plus 2. So you don't even have to think that hard about it. My recommendation is you get the endpoints of your radius and either do right minus left or top minus bottom, and that should get it for you. The height is what we get when we pick our x and plug it into the formula, or equation there, that thing. So there's the setup. Now the other issue that we need to talk about is I expect you to know how to integrate pretty much everything, unless it's super crazy and then you'd be able to use your calculator. But I'd be very comfortable not having you use your calculator here. As a matter of fact, we're going to finish this one. So what do? How do we integrate it? Tabular. Yeah, right, tabular. Not use substitution because I don't see a function and its derivative. So this one's definitely integration by parts or tabular. So we have x plus 2, 1, and 0. There's the derivative. The integral is sine of x, negative cosine of x, negative sine of x. And then plus and minus. We have 2 pi. The integral is negative x plus 2 cosine of x plus sine of x from 0 to pi. Two pi. I got to plug pi in. Negative pi plus 2, but the cosine of pi is -1. That makes that a positive now. There's the cosine of pi. Makes that positive. Plus sine of pi, which is 0. Minus, remember that's a -2, cosine of 0 is 1, and then sine is 0. So I get 2 pi times pi plus 4. So 2 pi squared plus 8 pi. Ooh, I am curious. 2 pi, let's do this very quickly. Math number 9, 0 to pi of x plus 2 sine of x. Oh, I'm in parametric, so that's why you see t's. 2 pi squared plus 8 pi. Bam. Got it. Got it. Now, as long as the setup's correct, which I'm pretty sure that is too, we're good. Use shell method to find volumes of revolution. Teacher note, do this one by hand. Do A by hand is what I meant. And the rest of the integrals, just use a calculator. Also show how to graph using parametric on calculator. Grab your calculators. We'll do this one more time. I've already shown you this, but let's do it one more time. And I'll pretend I haven't done it yet. Clear, 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 get out of that. Mode, you're probably in function mode. All right, that's where your calculator should be at. If we go to mode, go to parametric. So let's say that I gave you this equation, said rotate that around the x-axis in the first quadrant, and I gave you a calculator. So you want to get an idea of what this looks like. Now it says x equals, so we can't use regular function mode for this. So we'll go parametric, y equals. It says x equals this, so where it says x equals, that's where we're going to put the function. So t squared minus t to the third. In the y, we're going to put t. So where we're not putting the function, you just put t. For the window, we want this, you might have 0 to 2 pi here. It might look like that. Well, that's for trig. So we're going to do it for a regular function. How about negative 10 to 10s for t? This is actually pi divided by 24, if for some reason it's changed on you. And if I look at this graph, the window, I went 0 to 3. And then the y 0 to 2 seemed to fit nicely. We could probably make it a little smaller than that. But this seemed to do the trick. Now, if we're going to rotate this around the x-axis, if we're going to do washer, we have the same problem. And I'll erase this. If we rotate it like that, the problem is it's the same function on the top and the bottom. It has to be two different functions to do washer method. So this is tailor-made for shells. How about the halfway turn? Something like that, right? We pick a y value this time. So we pick a y value, and that y value halfway around would be there. So here's one shell, one cylinder. So we're going to do integral of from 0 to 1 of 2 pi. I need the radius. The radius, look, if you do the endpoints even up against the x-axis, here's the bottom of the radius, here's the top of the radius. If you do y minus 0, it's still, that's y. So you can do y minus 0. Well, the radius is y. And then the function value is the height of the cylinder. So times 12 y squared minus y to the third dy. I said we'll do this one by hand and then we'll do the rest with the calculator. So let's finish this one out. 24 pi, 0 to 1. I pulled the 12 out. That'd be y to the third minus y to the fourth dy. So distribute the y through. And I even have the answer, it's 6 pi over 5. So 24 pi, 1/4 y to the fourth minus 1/5 y to the fifth. 0 to 1, 24 pi, 1/4, which is 5/20, minus 1/5, which is 4/20. So 24 pi over 20, which is 6 pi over 5. You want to try B? Want to try to set it up? See if you can set it up. Whoop, whoop, whoop. We're not going over the x-axis again, are we? B. Oh, no. The line y equals 1. Oh, no. Let's not do the exact same problem again. Okay. Here, we're going over y equals 1, right? That's up here. That means the halfway turn is over here. So we need to get one cylinder. We need to be able to draw one cylinder on this. So that means we pick some y value. How about right down the middle, if you will? How about right at the top? That should be right at the top on the other one, so relatively speaking. So we circled that around. And we circle that around. Can you make the drawing? Can we do that? So there's one cylinder drawn, right? I know English. I'm pretty good at English. Not really. I'm terrible at English. I barely speak it. Now we need the radius and the height. So the next step is, we know it's 2 pi. We know that in this shaded region, the y's that we're going to be picking are going along this. So it's going to be 0 to 1. And we know that we're picking those y values for the edges. So we'll integrate with respect to y. Now I need this and this. There's the radius of this one cylinder that I picked. So what's the top of the radius? 1, and the bottom of the radius is whatever y value we picked, right? So 1 minus y. The radius is the top minus the bottom. And then the height is whatever y value we picked here between 0 and 1. Let's say it's 0.7. We plug 0.7 in to get this value over here. The distance from the y-axis to this is the height, which is the curve. So 12 y squared minus y to the third. So math number 9, 0 to 1. The answer is 4 pi over 5. So I need this to be 2/5. If that's 2/5, it's 4 pi over 5. So 1 minus y, or the variable. We're in parametric, so it has t's there. It doesn't matter. T squared minus t. Whoops. T to the third. What do I need? I need 2/5. 0.4, right? Math, 2/5. Then I multiply it times 2 pi, that's 4 pi over 5. We got it. We good? Let's try to set up C. It's okay to draw through the typing too. I think that's what we'll have to do. 1 3/5 is up here. And then if we keep extending this, then, I don't know, something like this. Up there. No, wait a minute. If there's a gap in between here, then there better be a gap in between up there. Oh, see what I'm saying? Yeah. So there's a gap here, so the top wouldn't be up against it. You'd have that symmetric gap there. I don't know if that was going to change your answer, but that's how you draw it. Yeah, you too. You didn't have the gap either, did you? Okay. Yeah, there's a little trick to draw these, you know. So now we need to get at least one cylinder. Doesn't really matter where you draw it. We need to get one of them. So roughly, here's one cylinder, rotated around 8/5. So we're going to have 2 pi, 0 to 1, because this is where we're picking our y's in that little area there from 0 to 1. And then this is the center of the cylinders, and then this is the edge. So this is the radius right here. So if we can find the endpoints, this is an arbitrary y right there. If we can find the endpoints, it's top minus bottom. So the radius is 8/5 minus whatever y we're on. And then again, the height is the function. So 12 y squared minus y to the third dy. Now the answer is 2 pi. So what do we need that to be? 1. We need that to be 1. Math 9, 0 to 1 of 8/5 minus the variable. We're using t's here. Times 12 y squared minus y to the third. Ugh, I almost had it. 1, there we go. Times 2 pi gives you that 2 pi. Did we do them all? Oh, did I put the drawing on D, didn't I? Oh, whoops. How am I going to do this? Oh, that's going to grab D. No, it grabs everything. Dang it. All right, I'm going to put it on C. All right, let's do D. I'm going to put D on C. Negative 2/5. Success. Negative 2/5. So down, I don't know, about right here, I suppose. Something like that. Drew a little too high here. Pick one, halfway around. Something like that. Integral from 0 to 1, because we're still picking our edges in that area there. 0 to 1, 2 pi. Here's the middle of the cylinders right there. That's what we're rotating around. There's the middle, and here's the arbitrary y that we've picked. So this is the y value. This is the negative 2/5 down here. So the radius is y plus 2/5, or y minus negative 2/5. And then the height is, again, is just the function value. So 12 y squared minus y to the third dy. You okay with that so far? The next slide is the first problem in your homework. So this is the first problem in your homework. Let's do letter A together. Let's set it up using cylinders, and then we'll show that you don't have to do the shell method every time. In your homework, I want you to do the shell method because that's the section we're on. I mean, that's what we're trying to practice. But I don't want you to think that we have to use shell method now. So set up letter A using the shell method. Go. And then we'll do the exact same thing. We'll find the same answer using washers. What are you doing? What are you doing?
Cylinder shell method?
Yeah, but did you graph y equals the square root of x?
Yeah.
Where's that?
It's reflected across x.
Isn't that square root of x?
I just put it across the y as well. Just for my own reference.
Oh, but your lines look straight to me.
Well, I know they're curved.
You know they're curved.
But
Okay.
if I keys, I'll put them as straight.
As long as you know they're curved, that's all I need to know. Okay, all right. That's what I was worried about. Y equals 2 and x equals 0. So we're looking at kind of this area right there. Now this is the point, 4, 2? So that would be 4. This is up here at 2. This is the point 4, 2. We're going to rotate this around the x-axis. So that means halfway around looks something like this. Now we need one, if we're going to do shells, we're going to pick one y value. Halfway around would be down here somewhere. If we rotate this around the x-axis, it's going to look something like that. So letter A, 2 pi 0 to 2. Integral 0 to 2. The radius, we rotate around the x, so the top is y, the bottom is 0, which is y. And then, we're picking y values. We're gonna integrate with respect to y. I need that to say x equals. So x equals y squared. Y squared. There's the height of the cylinders. 2 pi 0 to 2 of y to the third dy. Now, you don't have to do this in your homework. I want you to do everything you possibly can with shell method so that we practice this. I don't want you practicing washer or anything else. We've already done that. But let's do this with washer, and we can do it with washer because these are two different functions. We don't have the same function. We're rotating the parabola around, and we're rotating the line around. So this is pi integral from, are these stacking up, these washers, are they stacking up along the y or the x? What do you think? Yeah, because the next one would be like right here, or not next one, but another one could be that. So they're stacking up along the x-axis. So this is 0 to 4. The big radius is going up to 2. So the big radius is 2 squared. And the little radius is going up to the curve, which is minus square root of x squared dx. So my claim is that these two answers should be the exact same value. It's the same area, or excuse me, same volume. So 2 pi, math 9, 0 to 2 of the variable to the third. All right, there's the answer using shell. The next answer better be the same thing. Math 9, 0 to 4 of, what, 4 minus x? 4 minus x, or t. So it's not the same if it's not a microphone. Anyway, we got it, right? So shell and washer. On the homework, I want you to do this, of course. We want to practice shell. If this question would be on the test, I don't care how you do it. Just get the answer, right? And show the work, but get the answer. All right, how about a free response question? Let R be the region in the first quadrant bounded by the graph of y equals 2 squared of x. The horizontal line y equals 6 and the y-axis as shown in the figure above. Find the area of R. 0 to 9 of the top minus the bottom. 6 minus 2 squared of x dx. Before all of this rotation and all this stuff that we've been talking about, all you knew was top minus bottom when we did area. So don't start throwing weird stuff in here. It's just top minus bottom to find area. We're not finding volume on letter A. Don't overcomplicate it. 6x, so 2x to the 1/2. So add 2 halves. That's x to the 3 halves times 2/3, but there's a 2 there. So minus 4/3 x to the 3 halves from 0 to 9. I got the 54. 54 minus, let's see, 4/3, 9 to the 3 halves. Square root of 9 is 3. 3 to the 3rd is 27. 27 divided by 3 is 9. 36. I have no problem giving this to you without a calculator. Can you get it? I mean, that goes way back to, fractional powers and everything. My suggestion is you do the root first. Then you have really small numbers. I don't really want to mess with 9 to the 3rd. I could do that first, but I really don't want to. So do the root first, and it's usually not that bad. So the answer is 18. 18. Write, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. So I didn't make a lot of room. Here's y equals 7, and then this would be halfway around like that. So that's similar to one we just did. You can use shells. You can use washers also. Let's do shells. Pick an x value, pick a y value. Here's halfway around. I'm going to rotate that around. Whoops, rotate that around and rotate that around. So 2 pi integral from, that'd be 0 to 6. 0 to 6. And we need the shell. I need 2 pi r. Okay, here's the y. That's the bottom end of the radius. The top end of the radius is up here at where we rotate around 7. So I'm getting 7 minus y, and then the height is the function. But I need it to say x equals. I need that to say x equals because we're integrating with respect to y. So y over 2 is equal to the square root of x. X is y squared over 4. But we could do this, or pi integral from, now this, here's the inside circle, and here's the outside circle. I know it's getting kind of messy now. There's the outside circle. That would be 0 to 9. Outside minus inside. So I would need this radius right there. Here's the long one, which is 7 minus 2 squared of x squared. Big radius minus the little radius would be 7 minus 6. So just 1 squared dx. Like that. There, it's between 2 lines, so that radius won't change. That'll be the same all the way across. Or like my dad says, all the way across. Like, Dad, there's no T in that. It doesn't matter. He's like 75. He ain't going to change now. Questions on this? All right, well, you have the first problem. I don't know if you want to just go ahead and work on that right there. This is your first problem in the homework.